Hello friends, this video on States of Matter Part 19 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched Part 1 to Part 18. Let's understand the concept behind surface tension. So if you see this water, the way it drops is like this. See, it forms a spherical shape. And if you see, it forms a spherical shape like this. The question is why? Why it forms a spherical shape? Why not square? Why not rectangle? Why not cube? Why not cuboid? Why? So if you see here also, sometimes you must have seen the waters in the leaves, they form shapes like this. Right? Shapes like this. If it is in the air, it forms shape like this. Once it is dropped, sometimes form shapes like this. Also, if you see, if you have a glass and if you put a light pin very slightly, not with force, it will float. It won't go down. But if you shake this glass, the spin may go down, right? But if you put the spin very gently, it will float. Why it is floating? Why this is spherical, right? Why is this shape? Do we have answer to this? Do we know why this happens? This happens because of surface tension. We'll understand more on surface tension in the next slide. But these things, the pin floats, the water gets the spherical shape, the water droplets take particular shape, it's all because of surface tension. We'll understand the surface tension in the next slide. So what is surface tension? Surface tension is nothing but a property of water by the virtue of which the free surface of liquid, actually in liquid, possesses a tendency to contract so as to acquire minimum surface area. I'll repeat once again. It's the property of a liquid by the virtue of which it tends to contract to acquire minimum surface area. Why? Because if you see, let's suppose it's water, if there's a water molecule here, it is attracted all sides equally. There is no net force on this. Same thing applies for this guy. But the one in the surface, if you see, this particular molecule is getting attracted here, but the net force exists, right? Because if you see, there is no force from here, so there is a tension on this, right? This guy is willing to come down. Every molecule in the dark blue layer wants to come down. There is a tension created on this, and this tension creates a film kind of thing. This is found experimentally. This tension creates a film kind of layer on this, and on this layer, if you see, but this layer is very gentle actually. So if you put this pin very gently, it will float. But if you shake this, it will come down. But there is a very, very thin film kind of layer generated on this surface because of surface tension. Right? So surface tension is what? It is nothing but the property of liquid to contract to get the minimum surface area. And that's the same reason why this droplet gets this spherical shape. Because see, this droplet, they want to have a minimum surface area. And if you calculate mathematically, sphere is the one which has minimum surface area. For a given volume, if I have, let's suppose volume is constant, so if you find for that volume, you find the, if you make square, if you make cuboid, obviously you have to make three-dimensional thing. If you make cuboid, or if you make cube, or if you make sphere, or if you make cylinder, you can take any of the three-dimensional figure, you'll find that you find the sphere has the minimum surface area. So it gets this kind of shape to minimize the surface area. Right? So as I explained, the molecules of the surface experience a net downward force and have more energy than the molecules here. They have more energy. They want to come down. Right? And therefore, these liquids tend to have the minimum number of molecules in this, because all these molecules are suffering. They are all happy. These guys are happy molecules, but these guys are all sad molecules. Correct? And they obviously, if I'm a family person, right, I want to make sure each of my molecules are happy. They want to minimize the number of unhappy people here, but somebody has to be unhappy, right? Somebody has to be in the border, and they want to minimize the number of people or number of molecules who are unhappy. They always want to minimize the surface area. Correct? It is, you can say that it's a country and it's a border of the country. There are soldiers and they are unhappy. the normal civilians, they are happy. So any country want to minimize the number of unhappy soldiers. They want to do something so that surface, the border is less, right? Same thing here. You can relate things with the real life thing. So this liquid want to minimize the number of molecules in the surface area, and how it can minimize? By reducing the surface area itself, right? And if you see here, and that's the reason why we get this shape. And if you see, the surface molecules get attracted to the center, and this surface layer of the molecules act as a thin film. They are the protector. They protect the molecules. They are thin film on the liquid, and that's why you see spin floats on this liquid. Correct. Surface tension can also be defined as a force acting per unit length perpendicular to the line drawn on the surface of the liquid. So if I have a soap film, this is my movable rod. So if I apply some force on this, right, and with this force I move this film by x distance, right? So this forced surface tension we can also define as the force acting per unit length perpendicular to the line drawn on the surface. This is my fluid, and it has two film. So if I apply some force on this, and if you see the change in distance will be L into T into 2. Why 2? Because there are two soap films, one this side, one other side. So that force is nothing but my surface tension. So you will study more about the surface tension in physics. I think we have a big chapter on the surface tension, but in chemistry just understand that it is required because in chemical reaction we involve surface tension. And if you want to know more about surface tension, you can watch physics videos where the surface tension is well explained. In the chemistry we will not learn much about surface tension. We'll just learn that there is a film created, and with that film if you see this thing float. And also if you take this kind of structure where you have this rod and this is a soap here, and if you just pull this with the force, the total area of the soap will increase, right? But the soap will always try to minimize the area, so it will exert a force, and it will apply some extra force, and that is also called surface tension. Correct. And the magnitude of surface tension depends on the attractive force between the molecules. So the magnitude of surface tension is dependent on my attractive force. If the attractive force is more, surface tension is large. Obviously, logically it makes sense, right? And if we increase the kinetic energy of the system, the intermolecular force attraction will decrease, and thus if you see the surface tension will decrease as the temperature is raised. So if you have a glass and if you put one pin here, increase the temperature, you'll see that after some time it will come down because the surface tension will decrease on increasing temperature. You can do this experiment in your home. You can put this jug or something, one vessel, put some water in this, put in the gas stove, and first put a pin here, it will float. You heat it up, then you will see that after some time this will come down. Correct. Surface tension is denoted by Greek letter gamma, and it has dimension kg per second square, and in SI unit it is called Newton per meter. Correct. Surface tension is also defined as energy per unit area. As I told, it is also defined as energy per unit area. And with this you get a new unit of surface tension, that is joule per meter second, joule per meter square. So surface tension is either force per unit length or energy per unit area, right? Both these are surface tension. Now we'll talk about surface energy. See, as I told, the energy here is more than the energy here, right? So if you see that there is a difference in energy, this has more energy, this has small energy, right? Big E and small e. So the energy difference between the molecules at the surface and the molecules at the bulk. And this surface energy is nothing but surface energy per unit surface area. So the energy you have here, if you, let's suppose you have some energy here, divide by the area of this, that gives the surface energy, right? Energy by surface area, and its dimension is joule per meter square, right? And as I told, the spherical shape is because of the lowest surface energy, because the lowest surface energy, the lowest energy state of liquid is with the surface area is minimum, right? Because see, if you have more molecules here, it will have more energy because the molecules here has higher energy. Then everybody want to minimize the energy because energy is stress, right? So the lowest energy state of liquid will be, and has lowest surface area, and the spherical has shape has the lowest surface area. We explain that mathematically. If you see, if you compare for a given volume, cube, cuboid, cylinder, spherical will have the lowest surface area, right? Also, please note the unit for surface energy is identical to surface tension, because surface tension also I told we have two units, one is energy per area, one is force per length. So if the energy per area unit of the surface tension is similar to surface energy, and that's why we tell that the surface energy and surface tension are somewhere identical. So you will study more about surface energy and surface tension in physics for chemistry. That's all you should know. Just to clear some doubts if we have in surface tension and surface energy, let's see the difference between surface tension and surface energy. The first thing is surface tension has two units. One is Newton per meter when it is force per length, or joule per meter square when it's energy per area. But the surface energy has only one unit, joule per meter square. Surface tension is measured along a line. As I told, if I have this kind of structure, I have some soap here, you apply some force here. It's always measured across the line, where the surface energy is measured along an area. Okay. Surface tension is nothing but the net intermolecular force on the surface molecules of a liquid. So I have a liquid here, some liquid on this surface. So the net force on these molecules, on the surface molecule, is my surface tension. But the surface energy is nothing but the energy which these molecules has, right? So if in first case I am talking about the force, intermolecular force, IMF, intermolecular force between the molecules or surface molecules. In case of surface energy, I talk about the energy in surface molecules. Hope you understand the difference. So in this surface tension, I talk about the intermolecular force between the surface molecules. In surface energy, I talk about the energy of the surface molecules. Correct?
Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.